Okay, this video is all about simplifying square roots. I am going to show a method that can be used on any kind of radical, not just square roots. And it can also be used when you're simplifying radical expressions with variables, not just numbers. So that's the good part about this method. Okay, so first of all, there are two types of square roots that we deal with. The first kind we've already seen, the square root of a number like 25, which is a perfect square. You can just say, well, what's the positive number that if I square it, I get 25, and you come up with the answer of 5. So this is a rational answer, and it doesn't need a lot of overthinking. Now, the square root of 20, however, that's an irrational number. And there's two ways we deal with it. One, we get a calculator out and we approximate it to the nearest 10th or 100th or thousandth or whatever level of accuracy we want. Or we can just simplify this in the way that we would simplify a fraction like 8/12. We would simplify it to 2/3, so the numbers in it are smaller. We're going to do something similar with the square root of 20. All right, now to just understand all of this in general, we're going to be working with properties of exponents. And we do need to remember that radicals are rational exponents, meaning if you have a radical, you could write it with a fraction exponent. Specifically, square roots. That means you're raising something to the 1/2 power. So if you have the square root of a, and we are assuming that a is a positive number in all our problems that we're doing. If you have the square root of a, that's the same thing as a raised to the power of 1/2. So 25, that's the same thing. The square root of 25 is the same thing as 25 raised to the 1/2. Okay, now there's a couple exponent properties we'll look at. One of them is power of a power. So if you have a power like a to the nth, and then you're raising that to another power, say to the nth, that's the same thing as if you keep the base the same, a, and you multiply the two exponents. So we could use that to simplify something like the square root of a squared, the square root of a square. So this is the same thing as a squared raised to the 1/2 power. Since it's a square root, 1/2 power. Then I have the situation of a power raised to another power, so then I could keep the base the same and multiply the exponents. 2 times 1/2. 2 times 1/2 is 1, and then a to the first power is just a. So if you have the square root of a square, that will just work out to be the base of what's being squared. So back where we had 25 to the 1/2, that's the same thing as 5. So the square root of 25 is the square root of 5 squared, and you can just come up with 5. So anytime you have the square root of a square, that will just simplify to the base. All right, now, what about 20? 20 is not a perfect square. So we will use another exponent property if you have the power of a product. So a times b is a product, and if you're raising that to a power, you can raise each individual factor to that power. So the ab, the quantity raised to the power of n, is the same thing as a raised to the power of n times b raised to the power of n. All right? That will translate into something similar for our square roots. So if I had the square root of a product, a times b, I can just take the square root of a times the square root of b. All right? That's the one we'll use. It's true because the square root of ab is ab raised to the 1/2, and then that's the same thing as a raised to the 1/2 times b raised to the 1/2, and then each one of those is its own square root. Right? But this is the property that we will use. So if you have the square root of a product, you can break it apart into the product of separate square roots. So let's finally use that now on the square root of 20. Okay, so we're going to want to write 20 as a product. and we want to write it as a prime factorization, right? And this is what I spoke of at the very beginning. This method, we're going to use prime factorizations, and this will extend to not just square roots, but cube roots, fourth roots, and it also works when you have variables. All right, so to find the prime factorization of the number 20, you do a factor tree for 20. So let's break it apart. So 20, one prime that divides into 20 is 2, and it goes in 10 times. 2 times 10, that equals 20. Now 2 is a prime, so that's good. 10 is not. So now I'm going to take 10 and break it up. So 10 is also divisible by 2. 10 is the same thing as 2 times 5. All right, now 2 is a prime, we said, and 5 is a prime. So all the things I have circled, that's the prime factorization of 20. 20 is equal to 2 times 2 times 5, and then I'm going to write it with exponents. 2 squared times 5. Okay, so back up here where I have the square root of 20, I'm going to think of this as the square root of 2 squared times 5. Okay, now if I have the square root of a product, I can break it apart. So that'd be the square root of 2 squared times the square root of 5. So I've got separate square roots. Now, here is the square root of a square. That's what you're really interested in. Those simplify. So the square root of 2 squared is just 2. All right, now you can think in your head that that's the square root of 4, and that works out to be 2. That'll be fine. All right, now the square root of 5, that's going to stay just like it is, and it's irrational. So the square root of 20 simplifies to 2 times the square root of 5, right? Some people just say 2 root 5, or some people say 2 radical 5, but this is 2 multiplied by the square root of 5. All right, now let's try that with one more, the square root of 60. Okay, so you're going to need the prime factorization of 60. All right, so I've worked that one down here already. You can divide by 2 times 30, and then 30 you can divide by 2, and 2 times 15, and then 15 is 3 times 5. So we're going to have 2 times 2 times 3 times 5. Wherever you have a square, you have a double, this is going to simplify. Okay, so we have 2 squared times 3 times 5. Now, you could break this up into 3 separate square roots, but there's no need. You're just really focusing on the square. And you actually could just go ahead and simplify that if you want. The long way around is to write the square root of 2 squared times the square root of 3 times 5. Right? The square root of a square, that is what is going to simplify. So that'll be 2. Now this, you're just going to multiply it back together. 3 times 5 is 15. So that'll be the square root of 15. Okay, all right, that's the simplified version of the square root of 60. So in general, if I just make up something random, let's say I have 3 squared times 5 times 11. Okay, you can look at the square and know that part will simplify. So I always think of the square root as being like a jail. So anything that's squared, like 3 is squared, that one can escape. This can come out and just be 3. Things that aren't squared, they're stuck in jail. So 5 times 11 in this case, and so you'd have 55.